Hello to everyone. I'm glad to see you all here. My name is Kristjan Gildemann. I'm coming from ByteLife Solutions, and my everyday job in ByteLife is managing automation team. So my team is responsible doing different automation projects and also configuration management projects with our customers. And already today, it has been mentioned several times that good security starts from the infrastructure that is well functioning and well maintained. And the same often applies to the sports teams. So a good team is a team that knows its players, so everybody knows what other guys are capable of. They need to exercise together, and they have to be prepared. So they have to be prepared to meet their opponent on the field. And my goal today is to see, can we apply this concept also to the IT infrastructure and also to development. First, let's define the players. My presentation, the player means not only the people in the IT, not only the administrators, developers, architects, but also the IT components. So the operating systems, network equipment, firewalls, routers, servers, applications, frameworks, and so on. So to play together with them also. So both living things and not living things. So not living things, IT components, and living things, you in your IT organization, and probably also bugs, because everybody has probably noticed that bugs are also alive, because they move around and multiply all by themselves, and they don't need any external help, so they are alive. And we start analyzing this sentence basically piece by piece. So knowing your players, what do you have to know about your players when you are a sports team? First, you have to be aware what is the role of each player on the field. So you have your defenders, you have your attackers, your midfield players. And everyone on the field has the specific role. So you have to know in advance, you have to plan what is the role of every player. You don't need too many of them, because if you have too many players on the field, it's really hard. Again, the system gets too complex. It's really hard to orient between them. So you usually have your attackers, midfield guys, and defenders. You don't have the left, right wing defender that sometimes is on the left side of the field and sometimes on the right side field, or the attacker is also performing as a goalkeeper. So usually you have well-defined roles, not too many, but you have to have enough to fulfill the task. So you have to cover all the bases, basically. And you have to know your skill level. The skill level of every player. And you probably want to also set a certain expectation for the skill level. So you don't probably want to have a sports team where you have superstars like Messi, for example, in the football, and Sunday casual players who get together with their friends in the same sports team. Well, the reason is pretty simple. The Messi is probably unable to play if the Sunday players are, well, not capable of supporting him, and Messi is also a bit too expensive for the Sunday team, probably also. So you have to find a certain balance. You have to set an expectation of the skill level. So every piece in your IT environment basically has to apply to the same rule. So when you start gathering your team, you have to define your roles in the team. And the same applies to the IT environment. You have to define the pieces, the Lego puzzle pieces that you use to build your IT infrastructure. And again, on the last slide, you have to have sufficient amount of pieces to fulfill the task, but not too many. And the popular word standardization comes into the play here from the IT. So you have to select certain pieces. You have to select your operating systems. You have to select your application platforms, frameworks, and other equipment that you need to build your infrastructure. But you cannot go wild. I mean, it cannot be always exception next to exception. So a very good example is operating systems. In most of the IT companies, or any company with the IT department, you see servers, Linux platform servers, Windows platform servers, Solaris, whatever. And when you go deeper, what you see in the Linux group, for example, we have CentOS, SUSE, more, Debian, so on. And you have different versions. And it's quite common today, if you go to the IT environment and you look what usually in IT you have there. You have maybe SUSE servers, but you have SUSE 8, 7, maybe. You have 11 and so on. So it gets quite wide. The field gets very, very wide. And it's really hard to orient in this field. So if we look at the sports team and say we have basically in the football team 4 types of players, goalkeeper also, in the IT environment, we should apply the same rule. We should have a certain selection of equipment or software pieces that we use them. Why? Because it's easier to maintain. It's really hard to have the understanding of every type of operating system or application in the world. It's really hard to understand how exceptions are built into those systems. The same level, the same idea applies to the expectation of skill level, or the expectation to the players. So you have to always keep in mind that security is not just a borderline thing. It's not just a perimeter thing. Every component you play around in your IT environment has to be selected with the security mindset. You have to keep in mind that the weakest link in your environment probably is the place where the whole chain breaks. So you cannot allow a top-notch firewall when your website has a very simple cross-site scripting bug or SQL injection bug built into it. So every component, each and every component, has to be selected based on that idea. Exercising together. So if we have our roles and if we have players in those roles, we have to, to exercise, to make sure that they all work together. In the sports, we do trainings. We discuss game plans. We make sure that everyone in the team knows that if the captain starts to do some kind of a formation, everybody else follows. We have to have agreed configurations of the gameplay. And the same should apply in the IT. So after the standardization of the equipment and all the platform components, we should also look and find all the places where we can very clearly define the configuration of those components. And we also have to test them, which is really nice if you have agreed configuration for a certain area of your IT infrastructure that everyone follows. It's also possible to test it. Also the changes you can do, you can test those also. And those changes can be applied then in a little bit more safe manner than usually. From the security perspective, it's also important to remember that security is part of everything in the IT infrastructure. So if it's been very, very popular to talk about DevOps, ByteLife's last Spring conference was also about DevOps. well, if we look at the security, it's kind of a side business there. It's still, they are in their own silo in many organizations. DevOps has been hard to implement in many organizations. Now, including security into it is probably also a very interesting task itself. So, how do we achieve those goals? How do we manage to have a proper configuration control? How do we manage to have a proper testing? There are several tools out there already. Configuration management, Puppet, Salt, Chef, CF Engine, probably some more less known. What these tools allow you to do is to define your configuration, operating system configuration, your application configuration, network devices configuration in a kind of a declarative form. So you basically write a code how your infrastructure should behave. And one of your goals is to find areas or pieces of your infrastructure when you can create abstraction layers. So have big pieces of your infrastructure based on the same concept, the same algorithms. So all your Linux servers will implement the same configuration for DNS, for network time protocol, and so on. And they also are managed together based on those rules defined in configuration management system. Now, if your environment configuration is now defined in a code that is readable and writable for you and also for the machines in your infrastructure, what you can do is you can place this code into the versioning system. So we have several versioning systems already in use by developers for a long time. Just to mention a few of them, Git, Subversion, Mercurial, many others probably. What we can do here is we can have every next version of our code that defines our infrastructure versioned. We can always compare the differences. We can always go back to the last version. We can always branch away from them. So we can have several branches of the code. And later, of course, merge them back for the production. So the idea of development, pre-live, live staging environments comes also to the infrastructure world. It's very normal that companies have several environments next to their production environment where they play around and test their new applications. So you have either internal development or external development. And every new release of this new software is first tested or first developed in the development environment, tested again with other components, integration testing and so on, in the pre-live environment before pushing into the live environment. Now, when our infrastructure code is also written in this manner, what we can do is we can combine those two processes and really move from development through the pre-live staging to the live production environment with both application code and changes in the infrastructure. So what is really interesting is when you think it through, you can also automate the deployment processes through that. So you don't have to worry that after the application is written or the new version is released from the development process, that you have to write long documents how the IT operations has to implement this new software patch. It's quite often that we see those sheets of instructions where you have to copy this file from that directory to here, put that SQL sentence into the database, and after that you can restart some service and it magically works. And the next time the procedure is a little bit different. Maybe there's no SQL line, maybe there's 2 SQL lines. But having the configuration from the infrastructure and the application managed the same way, we can combine those processes. Automation from the workflow perspective is also very important. In every IT environment, we have some processes that we do very often. Creating a virtual machine, provisioning a network device port for a VLAN, many other. Having those tasks automated, having those tasks described in some programming language or workflow engine allows us to make sure that we do these steps always at the same way, and we can always test them and expect a similar output. And of course, process where we combine our security team into the development process here, where we also discuss those new releases that touch both infrastructure and applications, where we discuss this with the security guys. Well, that is a very simple next step then. So configuration management. I talked a little bit about configuration management, declaring your configuration. This is a very simple example how Puppet code looks like. What we have here is 2 resource definitions. The first one defines that we will have a user named Razor in our environment that has some kind of a group and a shell defined. And we also make sure at the next resource that we have a configuration file for some application, and this configuration file is owned by the user Razor. So quite simple, very easy to understand. So it's 2 commands in the Unix world: add user and change owner, basically. Version control. This is probably one of the places where we have to talk with the development team, because infrastructure guys don't always like developers. I know this from my own past when I was a true infrastructure guy, played around with the storage systems and Linux servers. Well, there are always bugs in the environment, and there's always 2 guys you can blame. First is definitely the network guy. Kalev was here before me. And the second one is the damn programmer who wrote this code. Why can't they write the good code? Well, to be honest, they have tried to do that always, and that's why they have those procedures of developing, testing, and pre-live, and then pushing it to the live. That's why they are doing version control. And this is something that infrastructure guys should learn from them. So if you are starting to move to the wonderful world of DevOps, then respect your developers, at least from that perspective. Automation workflows. There are many Orchestrator tools available on the market today. This is just one example of how a workflow in the VMware vCenter Orchestrator looks like. It's written by my team, I can say, so it looks really nice. But the VMware Orchestrator is probably one of the, let's say, one of the best hidden secrets in the VMware world. So everyone here who has a VMware environment, who has a vCenter license, the tool that allows you to define those, nice-looking workflows is available for you with the same license. You just have to install it, basically, and start using it. It might be hard for a normal infrastructure guy to start with, because it does require some programming. In many of those pieces here, they look nice and blue. There's actually some code behind them. So inside, if you right-click and say edit, you can see the code inside them. So it's a little bit hard to start, but it's very visual way of starting to do automation. Of course, VMware Orchestrator is not the only orchestrator that we can say exists in our environments. Cisco has their own orchestrator, Cisco Process Orchestrator. Microsoft has their own orchestrator named Orchestrator. Microsoft Orchestrator is also a nice thing. If you have a System Center suite already in your environment, it's also licensed inside there. So again, some licenses might be already present in your environment, but you just don't know about them. So what should you do with the automation workflows? If the configuration management of the existing systems is covered by Puppet, Chef, CF Engine, Salt, provisioning and deprovisioning is sometimes more reasonable to do with automating workflows. What you gain from there is, first, you make the process faster. So you don't have to communicate between different silos in your organization to have different parts of the environment configured for your resource or your service. And step here is deprovisioning. This is something that happened when the virtualization hit the world, was that everyone started to make virtual machines, but nobody really deleted them. So it was very cheap first because I didn't have to buy a lot of big hardware machines. I could buy just one and have maybe 20 virtual machines on top of them. But well, very soon you had 200 on top of them. So deprovisioning and keeping track of those processes is also very important. Enforcing configuration management. If all of your virtual machines or other resources are deployed using automation, you can make sure that they are also configured with your configuration management systems. You can enforce that they are deployed from templates that already have configuration management tools installed inside of them or will be installed after deployment. Automating updates to the configuration management database. Well, it's not the perfect solution of keeping the CMDB always 100% accurate because people are creative animals, but at least it helps a little bit. And always important is the possible step towards service catalog types of services where you can really offload your IT tasks to the end user where they can order the necessary services based on policies by themselves. So automating definitely helps to make that transitions happen. DevOps to DevOps security. Well, I tried with a few of my colleagues and also with a few of my non-IT friends, and I asked what security is. I mean, IT security. And let's say 70% of them said two things first. It was passwords. You have to have a secure password, and you don't tell it to anybody. It's like underwear. You don't share it. You have to change it often. And the second word was firewall. Virus defense was, or a virus defending software was a third one. So this is kind of an idea what the security is. It's network perimeter defense and making sure that we have really hard to guess passwords. Well, sadly, it's not that. If we talk about security with the developers, then for me it's always nice if they know something about the security, if they realize that their code that they are writing is also a potential place where a security hole may occur. So having development practices that also incorporate security testing and security security practices and really talking to the security guys before I commit the code is very important. So having, if you're doing agile development in your environments, in your IT environment, talking to the security guys once in a while, I mean, like every day, is not a bad idea. I mean, having them in the sprint plannings or morning meetings is not a bad idea. So use the information that they know. It's not useful to have a very good firewall if your website has a big hole. So if you're an internet bank and you have a big hole in your internet banking website, it doesn't help that you have a very good firewall. Testing. Already, I'm repeating everything that has been said today morning by keynote speakers. Having security tests in your, or incorporated into your normal testing procedures is always a good idea. There was an example about Jenkins, continuous integration tool, to incorporate security tests into those. But if you're not able to get that far today, just allowing your security guys to play around in your testing environment is also not a bad idea. And if we talk about network, then Kalev probably mentioned Cisco's application-centric infrastructure vision. Having a well-defined security policies for a specific application layer is a must in today's world. So consider also doing that. So I'm going to change the theme a little bit. So for the sports team, it's very simple. If we have good players, if we exercise together, so on, we will have a good team. The clean house kind of a theme is also very good. So if you keep your house tidy, surprise guests will probably not cause a panic mode cleaning. And if you're a bachelor, a guy that lives alone, and you leave your pizza boxes open every day, and your mother comes to visit, it's a pretty horrible moment. You have to make sure that everything is cleaned up in half an hour. So don't leave your cleaning when the cyber attack or instability happens. Make sure that your environment is clean and tidy every day. But it's not easy to get there because not everyone's houses are clean, I mean, all the time. I have a small child at home, and I'm pretty sure when I would go to the living room right now, it's full of toys. So it takes a while to find every toy in the living room to clean up the floor. So how do we get to the clean house? Well, in the IT world, first we have to realize that it's a lot more than just technical obstacles. It's not just a question about making sure that our Linux configurations are well defined. It's also about people. Sometimes your organizations has to do a pretty large transition from the silo-based environment where operation guys are good and developers are always doing mistakes kind of approach if you're IT infrastructure guy. It's otherwise around if you're a developer. You have to change that mindset. You have to really get friends with your operational guys, with your security guys, with your developers, and probably also with your management. Because if management doesn't really understand that kind of approach, and if management doesn't support it, it's really hard to push it through. I mean, there are many examples. Start with small subsets. Well, if you start cleaning, usually what you do is if I would go now home and have to clean my living room, I would have to do steps. First step, gather all the toys into the basket. And the second step, maybe vacuum. And then if I have time, maybe I wash the floors and take the dust also. So the same thing applies to to the IT, take a small subset, and start from there. It was a very, very nice example I can bring. We had about a year ago, or a little bit less, we had a kind of a small gathering in ByteLife office between us and a few other Estonian companies, and they're on the very different levels of configuration management and standardization. And one of them was pretty advanced, and the second party was a little bit starting the project, let's say. And the guy who represented the more advanced or more further on the road company said a very, very nice sentence was, start with something simple. For example, take all your operating systems and just select one Linux distribution and version and migrate everything to it. Very easy task. But you really have to select those subsets and take small wins on those subsets and basically move the whole stack. So start with the standardization and then configuration management and then automation and go through that subset with the whole path. That is my recommendation, at least. And then they take the next one, because this allows you to get more confident, it allows you to get more experience, and make the next subsets much more successful. Well, of course, there are different approaches for the cleaning also. I mean, if I go home and it's really dirty, I have some options. I don't like cleaning. I mean, there's dust everywhere probably, and then the simplest approach would be, well, to build a new house. I mean, if you build a new house, it's nice and clean. Well, the second option, of course, would be to listen to my wife and clean up the old house. But cleaning up the old house, there are always problems. There are problems like having this last batch of dust behind your TV set. I mean, in the IT environment, it's always the same. You will probably manage to clean up the mess in the majority if you really work with it. But cleaning up those small patches of dust that you don't mostly notice, but probably your mother-in-law will notice if she comes to visit, this is always the problem. So the last server, the last network port is always the problem. Building a new house, always a nice approach. In IT, luckily, it's not that expensive compared to ditching your old home and then really building a new one, but you can start step by step. So you can start project by project. So make agreements inside your team. What is the standardized platform? Create configuration management rules there, and start moving your new projects there. Just making the new projects there and allowing your legacy stuff just to die away slowly. Well, it takes a long time, and always they don't die that easily, the old legacy stuff. Or moving aggressively. Of course, there are different approaches. There are pros and cons here, but it's better to start now than to start when already somebody is knocking on the door. So having well-maintained configurations, standards, and automated workflows allows you at least keep the house clean a little bit better than acting on the last moment. So thank you from me. It was kind of a moral preaching story for you, nothing technical, but I hope that at least it helps you to find some confidence to start. So there are already in Estonia, in the world, companies that have been very successful with that. They will also face a lot of hitbacks in their process even today. But just carry on. Thank you. If you have any questions, I'm happy to answer if you have.